This section is about limits at infinity and horizontal asymptote. So what is a horizontal asymptote? Let's take a look at the blue function really quick. So we have f of x equals to x squared minus 1 divided by x squared plus 1. And then I have the graph. So the curve is the function. So what is the horizontal asymptote? So the horizontal asymptote is, so the HA horizontal asymptote is y equals to 1. How do you describe this using limits? So this is how we do it. So we write that the limit as x approaches to positive infinity of the function, the blue function. So as x approaches to positive infinity, so as x goes all the way to the right hand side, y approaches to 1. And then limit as x approaches to negative infinity, which is the left end of the function, that is also equal to 1. So therefore, the horizontal asymptote is y is equal to 1. Alright, so if you look at the table value, so let's say you let x be a very huge value. So let's say x is equals to 1,000. So if you plug in 1,000 to the function, you get something that is extremely close to 1. Not exactly 1, extremely close to 1. Because what is the characteristic of horizontal asymptote? It's like you are walking to the right hand side and you are approaching to this pink line. But the thing is, just treat the pink line as a wall, a solid wall. You are approaching to a wall. It doesn't matter how close you are, you cannot step inside the wall, right? You are approaching the wall. You are getting closer, closer, and closer, but you cannot step inside the wall. So that is the concept of horizontal asymptote. The blue curve is getting closer and closer to the straight line, but the curve will never touch or intersect the straight line. All right, so if you plug in a number like a negative 10,000 to the blue function, you will get something close to 1. So if you check out the table value, that is what you are going to get. And then the next question that people ask me all the time is, hey, this one, you gave me the graph. What if I don't know the graph? You just give me a function. Can we determine the horizontal asymptote really quick? It looks like this is something that I learned in the past, but I don't remember. Okay, let's review that. So let me change colors now. So you have x squared, all right? You have x squared minus 1 divided by x squared plus 1. What you have to look at is the leading degree. What is leading degree? Leading degree is the highest degree. So look at the numerator, look at the denominator. Find the highest degree for me. So this one, the highest degree is 2. I mean this degree. This one, the highest degree is 2. This is case 1. When the degree of the top, the biggest degree of the top is equals to the biggest degree of the bottom, the horizontal asymptote is the leading coefficient of the top. What is leading coefficient? Leading coefficient. Leading coefficient is determined by the leading degree. So the biggest degree is 2, right? So that means this entire term is the leading term. Then the leading coefficient is the number in front of the letter, which is 1. So this is equal to 1. So therefore, the horizontal asymptote is the leading coefficient of the top divided by the leading coefficient of the bottom, which is 1 divided by 1. That is equal to 1. Now, you might ask me, hey, I want to do a what if. What if this is a 3? What if this is a 5? Let me use another color. What if this is a 3 and this is a 5? What is the horizontal asymptote then? Then the horizontal asymptote is 3 divided by 5. So that is case 1. The leading coefficient of the top divided by the leading coefficient of the bottom. Now, the second question that you want to ask me is, hey, what if the leading degree of the top is less than the leading degree of the denominator? So let's change that to x to the first power minus 1 divided by x squared plus 1. Then what is the horizontal asymptote? When the leading degree of the top, this is 1, this is a 2, is less than the leading degree of the bottom, then the horizontal asymptote is y equals to 0. by the way, this is a y equals to 1. This is a y equals to 3 over 5. And then this is a y equal to 0. So let's say I make a change. I put a 10 in here. Does that affect the horizontal asymptote? No. I put a 99 in there. Does that affect the horizontal asymptote? No. As long as the biggest degree of the top is less than the biggest degree of the bottom, then the horizontal asymptote is y equals to 0. Okay, we don't care about any coefficient at all. What if the degree of the top is greater than the degree of the bottom? Then that one is the hardest case. So let's say you have x to the 5 minus 1 divided by x squared plus 1. Then what is the horizontal asymptote? This is hard. So in this case, there is a horizontal called slant asymptote. We have a slant asymptote, S-L-A-N-T, asymptote, or you can call this an oblique asymptote. This asymptote is not horizontal. This asymptote has some slope. How do you find that asymptote? The asymptote is y equals to something. To find that, you have to do a long division, which is out of the scope in this section. So you have to take the top, x to the 5th minus 1, divided by x squared plus 1. So whatever quotient you have right here is the asymptote that you are looking for. All right, so that is the basic concept of horizontal asymptote. Again, horizontal asymptote is like a wall. You are approaching to the horizontal asymptote only. You cannot touch or intersect the horizontal asymptote. Same thing on the left side and the right side. You are approaching to y equals to 1. You can never touch y equals to 1. Approaching. That's why we use limit as x approaches to, not exactly equal to 1. I mean, not exactly equal to x approaches to a number. So the function, the y value approaches to 1, but it's not exactly equal to 1. So let's do a couple example really quick. So as we scroll down, I have two graphs right there. So what I want you to do is I want you to find the limit and then determine the vertical and horizontal asymptotes for me. So the first one, we have x approaches to positive infinity and negative infinity. So positive infinity and negative infinity. So by the way, the horizontal asymptote affects the two ends only. I will talk about that after we go over the entire graph. So the limit as x approaches to infinity of f of x, which side should I look at? Positive infinity is the right side, which is right here. As x approaches to positive infinity, y approaches to where? Y approaches to negative 2, right? As x approaches to negative infinity of f of x, left end, y approaches to positive 2. All right? But you might say, hey, okay, asymptote, I can draw an asymptote for you. So let's use another color. So let's use blue. So this is my horizontal asymptote, right? And then this is my horizontal asymptote, 2 and negative 2. Then you might say, hey, hold on. Look, this point and this point, this point and this point, hey, they are touching the horizontal asymptote. You just said that the curve is approaching to the horizontal asymptote but cannot touch or intersect the horizontal asymptote. What's wrong right there? So to explain this, let me tell you, the horizontal asymptote affects the right end and the left end only. I don't care what is in the middle of the graph. I am looking for the right end and the left end only. The graph, the middle, these 4 points, I don't care at all. All right. So what about x approaches to 1? So x approaches to 1 from the left and from the right. So this one is positive infinity. So as x approaches to 1, let's just make it fast. So x approaches to 1 from the left. We have y approaches to positive infinity, right? That is another way to write a limit. As x approaches to 1 from the right, the function or the limit, you can say the limit approaches to positive infinity. So therefore, we have a vertical asymptote at x equals to 1. And then this is a 3, right? So we have a vertical asymptote right there. So as x approaches to 3 from the left, we have y approaches to negative infinity. As x approaches to 3 from the right, y approaches to negative infinity. So therefore, this is infinity, this is negative infinity, right? And then this is positive infinity. So what is my second vertical asymptote? My second vertical asymptote is y is equal to, not y, x is equals to 3. What about the 2HA? So for the 2 horizontal asymptote, we have to switch color. So we have y equals to 2 and y equals to -2. When you do your work, I don't want to see 2, -2. That is not a complete answer. Y equals to 2, y equals to -2, because that is horizontal. The vertical asymptote, I don't want to see 1, 1, and 3. That is not right. That is not complete. I want to see x equals to 3 and x equals to 1. All right? Don't just say 1, 1, and 3. I don't know what 1, 1, and 3 are. X equals to 1, x equals to 3. So we have another one right here. All right, so that is the first graph. The second graph, what do we have right here? So the second graph, we have a limit as x approaches to positive infinity and negative infinity, right? So here is a positive infinity, and then here is a negative infinity. Let's switch color. So as x approaches to positive infinity, what do we have? We have y approaches to 2, right? So this is equals to 2, and then limit as x approaches to negative infinity of f of x, we have -1, right? So we have -1. So we have 2 horizontal asymptote. No, not 2 and 1. Y equals to 2, y equals to -1. I don't want to see 2 and -1. I want to see y equal. And then you have the 0. So x approaches to 0. So x approaches to 0 from either side. So left side and right side. So limit as x approaches to 0 from the left. Limit as x approaches to 0 from the right. What do we have? They are both negative infinity, right? So negative infinity, negative infinity. Then this is negative infinity. 2 from the left. Where is 2? Here is 2, right? So left side, we have negative infinity. Right side, we have positive infinity. So where are the vertical asymptote? We got one right here. And then we got one right here. So we have 2 vertical asymptote. We have x equals to 0 and x equals to 2. I don't want to see 0 and 2. I want to see x equals to 0 and x equals to 2. So that is the basic introduction to limits at infinity and horizontal asymptote. In the next video, we will evaluate some limit involving infinity. All right, so I will see you in the next video.